Well, welcome to Mission Control in Houston. My name is Pat Ryan. I'm the Public Affairs Officer on the Orbit 2 shift here in Mission Control today. And we've just finished up our live update on the activities on board the International Space Station. And happy to join you and get to tell you more about NASA and about the space station, what's going on. I've invited along another one of our flight controllers who works here. Ken Neiss is a CRONUS specialist. And we're going to find out what that is after we first find out about you. What is it, your professional background? How'd you end up at NASA?
Okay. Well, I grew up in the Philadelphia area, Philadelphia, Pennsylvania suburbs. I was always proficient at taking things apart. To my parents' dismay, they labeled that breaking things. But I
Parents are
always
like that.
wanted to see how things worked, and along the way, I had was very good at math and sciences. So I pursued the field of engineering when I went into college. I went to Penn State University, got my undergraduate and my graduate degree at Penn State, and at that point, I got recruited by NASA at one of the college fairs, career fairs, and I've been working here ever since.
Let's find out, as I said, we're going to find out what a CRONUS does because I imagine that that's one of the first questions that we're going to hear. We're ready to hear what the kids in Little Rock have to say.
Good morning. My name is Danielle Ray, and I'm in the 8th grade. And I have a question for you today. Could you name one or two conditions that could negatively affect operations for the flight control team?
That is a really good question. There are a couple things that could negatively affect us down here. The first is loss of communications. One of our main ways to figure out how things are going on the space station is via the telemetry and data receive on the ground and by actually talking to the crew. If we don't have those links, then we don't have a way to talk to the crew to figure out what's going on or to intervene from the ground and fix anything. So it's really important for us to try to utilize our communication time frames as best as we can. Another thing that could negatively affect us is a malfunction. If something does go wrong, everything that's scheduled for the day, depending on how big the malfunction is, the whole day could be wiped out. So it really depends on what the malfunction is, but those are some of the big things that can really affect the ground controllers, us here on the ground, the flight controller team.
And particularly for you, for a CRONUS officer, explain what it is, what systems you guys are charged with maintaining.
As a CRONUS, we are in charge of those communication pathways. So the voice, the commands, the data we get from the space station, the video that we get down from the space station, all the health and status of our systems, of our payload data, our science data comes down through the systems that I manage. So that's what we're in control of, and it's a really fun job.
Next question.
My name is Kyle Holmes, and I'm in the 8th grade. About when will the flight controller downlink the command history logs? Daily, weekly, monthly, or when?
That's another
Very specific.
Yeah, it's a very good question. Part of my discipline, we're responsible for the computers and downlinking those logs, like you talked about. We downlink detailed data from the main computer about once a week on a Sunday afternoon. We get more detailed data from the crew's personal computers they use to command and receive data from the systems. We downlink that about once every month. Behind me in the background, we do get real-time command history data. Basically, all the commands that we send from the ground, we get a log of that, and we are constantly saving that. So for historical purposes and to see what has happened.
Mm-hmm. Good. Who's next?
Thank you.
Hi, my name is Jonathan Jordan, and I'm currently in the 8th grade. I have two questions I would like to ask you. The first one, where exactly are the multiplexer computers located on the International Spaceship, or also known as ISS?
Okay. Um, the multiplexer demultiplexers. Sorry, it's a hard word. Basically, our main computers are located all throughout the space
Because
station.
there are very many of them.
There are over 40 of them. So we have three tiers of these main computers, and some of them are located inside, some are outside. Some are inside the lab module in various racks. Some are in end cones. Some, in the, like I said, in the lab, Node 2, Node 3, airlock, the PMM, and then there's a whole bunch outside on the external trusses. So they're everywhere, and they need to be everywhere to do all the jobs that they're responsible for.
And the multiplexer, demultiplexer computers, is there a way to characterize the level where they are? They're not just the standard laptops that the crew interact with all the time.
These are the computers that range from directing traffic from the sensors and effectors for the data we're trying to gather, to passing it up and interfacing with other modules or other international partners, all the way up to our prime computer, which is responsible for putting together all the data, being the crew's interface, and shipping that data where it needs to be, such as the ground or the crew's laptops.
Good. Next one.
And my second question is, how many channels does the Q-band communication systems have?
The Ku-band system, right now, we were able to get 6 downlink channels, 6 downlink video, either HD or standard definition, in addition to ability to talk via IP phone, Internet Protocol phone, to the crew. We can even send email through it. We can ship live video for the crew to use, and also bring down payload science data through that Ku-band link.
And the 6 channels is a fairly new development.
It is. Over the past less than a year, early this year, I should say, March, April timeframe, we expanded our capabilities from 4 standard definition downlinks to 6 combination high def or standard definition video.
Thank you.
You're welcome.
Hi, my name is Zakara Floyd, and I want to ask you, how many tracking and data relay satellites does the U.S. have?
So the U.S. has, I believe, 8 of these satellites that we can use. What the International Space Station uses for communications is only 5 of them. So we have the options to use 5, which are located in various parts in relation to the Earth. So 5 of the 8 we use.
Thank you.
Hi, my name is Contavian Blevins, and my question is, why does the antenna have to move to collect data?
Good question.
They studied up for you.
Yeah, they did. Trying to stump me. The antenna has to move because of the design of the systems, basically. We need to get high rate of information, high amount of information down, and the easiest way to explain that is the higher the information, the smaller the beam width. The antenna can radiate in a given direction. So if we have a small beam width, a small area where you can actually see or transmit the data, then you have to be able to move that small distance to track the satellite. If we don't need as big, or if we don't need a high amount of traffic, we don't need as big of a beam width. So we can have a bigger beam width and not have to move the gimbals for our antennas.
And I believe part of the reason that the antennas move too has to do with the TDRS satellites, because you have to point the antenna at the satellite.
Exactly.
And the station is moving, but the satellites are not relative to the Earth.
Exactly. As the TDRS is moving, the station is moving, and it all has to be in sync to lock up to each other. We do have some parts of antennas that we can fail over to that are considered low rate that don't move. They're like omnidirectional, almost omnidirectional, and it gets part of the sky. But other than that, if you want to transmit about a higher amount of data, you're going to have to track the satellites.
Yep.
Thank you.
Hi, my name is Zay Cornborough. I have one question for you. How do you know when asteroids are coming to the ISS?
Wow. Yeah, the asteroids are a tough one. We have a specific flight controller in the room called Topo. They're in charge of all the monitoring and the trajectories of any types of debris or objects that could impact the space station. And they talk to one of their counterparts called Stratcom. And those two positions monitor all the time whatever is available to see. They've got lots of radar and satellites that they can monitor this information and hopefully alert us if we have any potential asteroids coming. Now, the smaller the asteroids, the harder it is to monitor and the less notice we get.
The harder to see.
The harder to see. The bigger they are, hopefully we get enough notice to watch out.
And they're watching not just for asteroids, but they're keeping track of all of the junk that's in space. There's over the course of 50 years or more, as people have flown in space and they have left garbage up there, there's more things that are up there. And so we have to keep track of even small objects, because if they were to collide with the station, they could cause some damage.
Yeah, you got to understand that all those objects have a trajectory and a speed and velocity. So if we're going in a different direction than that, it could have a real dire effect, and we're traveling really fast.
Okay, next question.
Hi, my name is Raquel Foster, and I'm in the 7th grade. Have you ever sent a video to space?
Have I ever sent a video to space? I can't say that I have sent a video to space. We ship the astronauts video all the time. Me personally, no. We are probably shipping them video as we speak right now. During the crew off-duty day, we can ship them live TV, as long as we have that link that we talked about between the satellite and the space station. But no, I have never sent video up. The closest I've gotten to sending video is sending a picture up to the astronauts when my daughter was born in December, and they were pretty stoked about seeing that, and they gave me some congratulations.
But we do send video to the crew all the time. As Ken says, they get video that is training video that helps teach them how to do things. They get video, live video from their families. They get a chance to have weekly video conferences with their families, usually on the weekends. They can get video from in this room sometimes of events that happen in this room that gets sent up to them. So it happens a lot.
Yes, it does.
Thank you.
Hello, my name is Cedric Williams, and the question I have for you today is, what would happen if there was a malfunction in the IAS internal audio system during an emergency?
And you said that during the internal audio system during an emergency?
Yeah.
Interesting question. So, what would happen during an emergency? It would depend on the malfunction of the audio system. Normally, during an emergency, we alert the crew that there is an emergency if they weren't the ones that detected it via the tones that are produced by the audio system, to let them know, hey, there's an emergency, you need to take some actions. If there's an emergency and they know about it and there's an audio malfunction, they're trained on the responses. It's almost ingrained. We train the emergency response very hard and very often. So they'll just go on muscle memory. They'll go to their procedures and they'll just go perform the actions if we don't have a link, if we don't have audio with the crew. Hopefully the failure would be one where we still have audio with the crew or audio tones, but it would impact the ability for the team on the ground to be able to follow the crew and for the crew to be alerted with all their normal signatures.
You
really
might
good
have
question.
to rely on the data that's still coming down, but without the ability to talk to them.
Exactly.
Okay.
Thank you.
No problem.
My name is Isaiah Perry, and I am in the 7th grade. We know that NASA suffered budget cuts in the past. Will CRONUS be affected by those budget cuts?
Will CRONUS be affected by the budget cuts? Probably in some ways. We have already merged with some. We had originally were communication systems in one discipline and computer and data systems in another discipline. We have since merged into CRONUS to combine that. I don't foresee any additional impacts to the budget cuts, but it's too early to tell. I think we're pretty stable.
Okay, next question.
Hello, my name is Elbriana, and my question to you is, what is the machinery you use to send important information to ISS?
You said the machinery used to or to transmit information to ISS?
I'm not sure. Can you repeat the question?
Make it louder, LB.
What is the machinery you use to send important information to ISS?
Okay. To transmit and receive information, that's a good question. We use various pieces of equipment on the ground. Our main interface as a flight controller is our Linux workstations. You can kind of see one in the background here. It has command interfaces and data interfaces and interfaces with the ground systems. So it puts together what we want to do. It sends it off and puts it into the data stream and the command stream, and at some point it adds the audio information from the voice channels that we talk to the crew, and then it gets encrypted and combined and shipped up to the satellite. It's shipped over to the space station, and it's been received by a satellite dish on our space station called the radio frequency gimbal, RFG. So at that point it brings it into the S-band system, gets pulled out into, it gets decrypted first, and then gets pulled out into audio data, which goes to the audio system, and the system's data, command data that goes into the main computer, and the main computer will then ship it wherever it needs to go.
Simple as that.
Simple as that.
Okay.
Thank you. My name is Christina, and my question is, how are commands and data sent between MCC and ISS?
How are commands routed between MCC and ISS? We talked a little bit on the previous question, but the commands we have a set list of commands that we can choose from. We've tested in various settings, and we can choose it on our Linux workstations. Our Linux workstations has an application interfaces with the command system. We choose a command, we hit, basically hit that we want to send it. It gets added to the stream. It gets combined with the audio system. It gets encrypted, so only the commands we want to send get onto the space station. It gets added to a radio frequency signal. It gets embedded into that, and it gets shipped out by White Sands to the satellite. The satellite will then relay the entire stream over to the S-band system, and it'll get pulled out from there and shipped along where it needs to go. The main computer will detect whether or not the command is valid and send it to where its destination is, which is part of the header in the command field. Mm-hmm. And it'll go from there. We can ship commands to all different parts of the space station. We can even ship information between modules, between segments, and so forth.
And despite the tearing those commands apart into the pieces so they go where they need to go, I think it's interesting to note too, as you said, that the path that information takes to get from here to the station is not a straight line.
No, it's not a straight line.
It goes from here to New Mexico to the satellite to the station.
That's correct.
Hello, my name is Latia Pope, and we know that there are several countries working together with the ISS. We want to know, how do they work together?
How do we work together? There are a lot of countries that we're working with the ISS right now. how we work together is we have lots of meetings, lot of get-togethers with our partners. Sometimes we talk to them over the phone. Sometimes we talk over in mission control to them via telephone systems. Is what's called device behind us. We can listen to dozens of loops at any given time, and these are patched into Moscow. They're patched into Japan. They're patched into Europe. Patched into Alabama. It can be patched almost anywhere. So we could talk to them real time by those methods. And we have a pretty good relationship with all our partners. Some partners, the Russians, require extra translation because we speak English, they speak Russian.
Right.
So it requires an extra person involved, and both teams have sets of translators that assist us. So we make sure we communicate the correct information to both sides, and the other side receives the correct information. But we have a pretty good symbiotic relationship between all the countries working together.
And that's, as you say, it's 16 different countries now that are involved, and the device that you talked about, I know you can't see it too well on television, but from this panel right here, we can punch buttons, and through the headsets that we're wearing, we can talk to not only everybody else in this room, but other people in this building, and in Russia, and in Germany, and in Japan.
And this is the same system that certain people can talk to the astronauts up in space right now.
Right. Next question.
Okay. Did we have some more? I know some of you had 2 questions. Do any of you have any additional questions to ask? All right. If I may, I'd like to ask a question, and that is, what different career fields are now? Everyone thinks of NASA, they think of astronauts and things like that. What are some of the different career fields available at NASA?
Well, I'm glad you asked that question. I forgot to tell you my backstory. I'm actually, I alluded to it, but I'm an engineer, and I actually worked in the field. I studied in the field of electrical engineering, communication systems. There are a lot of engineers here, a lot of electrical engineers or aerospace engineers that work here. Some people that work here are pure scientists. So pure science is either research or research or payload type science. Other fields are medical fields. There's a lot of medicinal requirements. Doctors.
There are writers. There are people who know about business operations and insurance.
Finances.
There are people who run the buildings. There are all kind of occupations who are needed working in NASA.
Yeah, it really takes a whole plethora of different types and different fields to work at NASA, even Johnson Space Center. And it's really diverse background.
Okay, we have time for one more question if you've got it there.
Okay, looks like we have a few shy folks.
Okay.
One question. All right, we have a question. Come on up, Atari. Hurry up. We got hurry along.
My question is, who designed ISS and why?
Who designed ISS and why? Another good backstory question. Please correct me if I'm wrong.
And the short version?
The short version is that we were building a space station called Space Station Freedom. We were planning on one, and Russia had partially built Space Station Mir 2, and Europe had proposed a certain module, Columbus, and we all kind of decided to pool our resources and create an international space station.
But yeah, a lot of people were working on different things, and it started to come together as a group back in the 1990s.
Yes.
And I think that's about the time we have. Ken, I want to thank you for joining us here and for some interesting answers and learning about what's going on here. And we'll send it back to the DLN.
And thank you, everybody. Great questions.
Thank you.